So we're going to look at determining if a relation is a function. So let's start with this. There's going to be 4 different ways, which I left off the 4th, but there's 4 different ways that you're going to be shown a relation, and we'll talk about that in a second. But you're going to get a table, you're going to get a graph, you're going to have mapping, or you could just have an equation, and that equation essentially is going to give you what the relation would look like. Okay, now, just real quick, a relation is basically a set of ordered pairs. Okay, so I'll just write that real quick so you can see it. So relation is basically just a set of, and then there's going to be a bunch of x and y values. Okay, and so those are the 4 different ways that you could see this information given to you. So now let's talk about 2 things involved in a relation. So you have something called the domain, and you have something called the range. So real quickly, we'll just go over those, okay? So the domain is just the x values of your ordered pairs. So when you hear domain, that's just the x values. When you hear range, it's just the y values. So like I'll show you a quick example. Let's say that I have an ordered pair. I'll just put 2 ordered pairs up here. -2, 1, and I don't know, 0, 0. Now, if I wanted the domain and the range, once again, the domain is simply just the x values. So remember, in an ordered pair, the x value is just the first coordinate in that ordered pair. So -2 is an x value, and then 0 is an x value. So that's my domain. My range is just the y values. So remember, that's the second coordinate in the parentheses for an ordered pair. That would be 1 and 0. So I could say 0, 1, and it's that simple. That's how you find the domain and the range. Now, the last thing we need to go over when we are determining if we have a function is we just need to check our x values, and I'll show you why. So I would write this down. So a function happens, so we'll say yes, it is a function, and it's on the condition that, so we'll say when the x's do not repeat. Okay, basically here's what can't happen. For something to be a function, the x values can't be used more than once. Okay, I'll show you on a graph what it looks like because it's easier to understand, but very simple. If something is a function, you say, yes, it is a function if the x values do not repeat. But let's say the x's do repeat. We would say, no, whatever we were just given, no, that is not a function. So let's practice a couple with ordered pairs, and then I'll show you the graph. So let's say we have, I'm going to give you a big set, and it's going to have some ordered pairs in it. So -1, 9, no, -1, -9. So that's an ordered pair. 0, -5, that's our other ordered pair. We're going to have 2 more, 4, 3. And then we're going to have 1 more, 6, -2. All right. So our job is first, we're going to figure out what's the domain and what's the range. Okay. So the domain, once again, see if you can pause the video and figure out the domain. It's just the x value. So if I go through and look at each of these ordered pairs, the first coordinate is just the x value. So my domain, and I'm not even going to order these from least to greatest, or actually, yeah, I guess I will. But it would be -1, 0, 4, and 3, or 4 and 6. All right, now, same thing with the y values, except now y means range. So range and y value goes together. So now we just look at the second coordinate and find the y values. So -9, -5, 3, and -2. And I mean, technically, you may want to put these in order from least to greatest, but right now it's just not a big deal. All right, so now last question will be, is this a function? So it'll ask something like this. It'll say function, yes or no. All right, so now once again, remember, if something is a function, that means the x's do not repeat. So let's just look at all these x's. We have -1, 0, 4, 6. I did not say any of those numbers more than once. That is a function. As long as this is exactly how I do it. I say the number in my head. As long as you don't say an x value more than once, then yes, it's a function. All right, let's do one more, but I'll give you a table because sometimes you'll see the graph given to you as a table instead of an ordered pair. So let's say I have a table and it looks like this. Let's say I have an x, I have a y column, and I'm just going to list off the values for my ordered pairs. So we'll say that this is 5, -3. We'll say this is 5. We'll say 8. All right. And then my y values are going to be, let's see, 2, 4, -6, and 0. Now, the only difference between the ordered pairs I gave you and the ordered pairs that we're looking at now is these ordered pairs are just given as a table, but it doesn't change anything. If this x value is 5 and this y value is 2, that means the ordered pair is 5, 2. Okay, so they're basically, in my opinion, giving you an easier way to look at this because you know the domain is all of these x values. You know the range is just all these y values. So if it asks you for the domain and range, well, here's the domain and here's the range. So now let's answer this. Is this a function? Yes or no? All right, so now remember, all we care about is, do my x's repeat? So let's just go through and I'll even do it as I would be doing it in real life. In my head, I say 5, -3, 5. As soon as I hear the second 5, I go, okay, I know immediately that's a no because x's, for a function to be a function, the x's cannot repeat. So as soon as I see these two are both repeating, I say, nope, there's no way that's a function. All right. So now let's move on to one more example. And actually, I think we can just go straight to the graphing. I don't think we need another example. So let's say I have a graph, and I'll put a graph on here real quick just so you can see it. So let's say I have an x and a y axis, and I'm just going to put a bunch of random points up here. Okay, so you don't really have to go through and overthink these, but let's just say I have a point here, I have a point here, and let's say both of those are at, let's just say that is -3. Okay, so then I could have a point over here, I could have a point, I don't know, down here, and let's just say there's another one down here. Now, when you're looking at this graph, it's easy to go, I have no clue what I'm looking at. I don't know what's a domain and what's a range. Well, first of all, if something asks you for the domain and range here, your job would be to find the ordered pair that corresponds with each of these points. So that's just the ordered pairs that's going to go in for this and this. But the real question is this a function? Or how do we know if it's a function? And here's how you do it. There's a test. It's called the vertical line test. All right. So essentially, here's what the vertical line test says. It says, I can't cross or I can't intersect the same point with a vertical line. If I do, that means it is not a function. So actually, let me write that out. I'll say, we would say yes. So yes, if vertical line, we'll just say intersects, or yeah, let's just say intersects. Intersects. So yes, if the vertical line intersects only one point at a time. So only 1 point at a time. So here's what we mean. I'll get rid of all this just so you can see it. So the vertical line test basically says this. I should be able to draw a vertical line through each of these points. However, I can't cross any of these points at the same time. So watch what happens. If I draw a vertical line here, I'm only intersecting this point. So that point's fine. If I draw a vertical line here, once again, I'm only intersecting this point. So only one time, that's what we need. So thus far, we would say, yes, this is a function. Same thing for this point. If I cross this line with a vertical line or intersect it with a vertical line, I'm still good to go. The issue would be these two. If I were to draw a vertical line at x equals -3, I'm crossing these 2 points at the same time, and that fails the vertical line test. So we would say, no, this is not a function. All right, now, let me show you a couple more because I know that can be confusing for some people, so let me show you a couple more. So, once again, let's say we have a graph, and I'll make this line look like, let's just do it like this. Let's just say that's our line, that's our relation, and we're trying to decide, is this a function? And we're going to use the vertical line test. Now, instead of there being specific points, I just have a line. So, once again, I should be able to draw a vertical line anywhere on this graph. And if this is a function, that vertical line will only hit this line one time per vertical line that I draw. So let's just say I draw this vertical line. I'm not intersecting this purple line or this initial line that I drew. I'm not intersecting that at more than one place. I'm only intersecting right here. And I could do that an infinite number of times. I could just keep doing this. And if you look, every single one of those points only crosses my line one at a time, or one time. That would be, yes, that means it passes the vertical line test. So, let's look at one that's a little bit harder. Let's say I have a graph that looks like this. So let's say my graph has, we'll draw it kind of like this. Yeah, that looks fine. All right, so here's my graph. So now I want to decide, is this a function, yes or no? And remember, we can use the vertical line test, and honestly, you only need one vertical line, because if you draw a vertical line straight down the middle of this, you can see I'm intersecting at two places. I'm intersecting here and here. Once again, this would be like the x's. Remember when we did ordered pairs? We said the ordered pair x can't repeat. Well, essentially a vertical line intersecting the graph at more than one place, that means the x's are repeating. So we would say, no, this is not a function. Let's look at one more just so you get the idea. Let's say I had the graph of a circle. So let's just say I have a circle. This is going to be a horrible circle, but imagine it's not. Actually, wasn't too bad. All right, so let's say this is my graph. And once again, I'm just asking, is this a function? So we're going to use the vertical line test, and I can draw a line straight through this graph. And as long as I intersect at only one line, or as long as I intersect this graph at only one place, then I'm fine. But if you notice here again, I intersect this circle here and here. So immediately it's a no. All right, so once again, for the vertical line test, the x's still can't repeat. But now instead of us drawing out a bunch of x's, all we do is say, okay, the vertical line test, each vertical line can only intersect my graph at one place. If it intersects at more than one place like this, then we say no. Okay? And then remember for if I want the domain, that just means the x's. If I want the range, that just means the y values. And then if I want to know if something's a function without a graph, then I use this rule of thumb. I say yes as long as the x's do not repeat.